Okay, guys, welcome to Friday, and today we're going to be looking at standard normal distribution. Now, what we looked at yesterday was a normal distribution, and we could have any mean and we could have any standard deviation. And there are infinitely normal distributions, but there's only one that has a mean of 0 and a standard deviation of 1, and that is our standard normal distribution. So if we look at our normal curve here, with a standard normal distribution, we have this mean here at 0, and we have a standard deviation. This distance in between here, our standard deviation, is just 1 unit. The area under the curve still equals 1. Everything we talked about yesterday is still true. Z-values are going to represent values in our standard normal distribution. And what a z-value is we're going to transform our random variable x's to a z-score so that we can normalize them and look at them under the standard normal. So a z-score, to do that, you take your value, subtract the mean from that, and divide by the standard deviation. And so we're transferring them into z-scores so that we can compare apples and oranges. Now, to transform a z-score to the data value, to do the reverse of that, the data value is just going to be the mean plus the z-score times the standard deviation. So these are the two we're looking at, and I'll give you several examples on how we're going to use these today. Okay, use the z-score table and your calculator normal CDF to find lower bounds and upper bounds given the following z-scores. So, you should have been handed a z-score table along with these notes for today. So first thing we're going to do is we're going to find the area under the standard curve that is to the left of a z-score of -0.99. So pull out your chart, and I'll pull mine out with you. So we're going to look for a z-score of -0.99. So we come down this, because this is my negative here, and this is my positive side here. So I'm going to look down the negative till I get to -0.9, and it is right here. Then I'm going to look over until I get to the 0.9. So that gives me this data here. And what is the value of that score? So the z-score for a z-score of -0.99 yields 0.1611. So the area under the curve to the left z-score of -0.99 is 0.1611. So if we were looking at this in terms of our problem, we converted and we found a z-score. What is the probability that it would be less than that? The probability would be 0.1611. We read the z-score chart. These numbers give us the area under the curve to the left of that area. The area under the curve to the left of that z-score. Okay, so that was our first one. -0.99 gave us this value here. All right, the next one. Find the area under the standard curve right of positive 1.06. So we go back, we look for positive, we're in this column now, 1.06. Let's find 6. Well, this value here, the 0.8554, represents the area under the curve to the left. So what we're looking at, when we look at a z-score of 1.06 and we want to the right, if we think about our little curve, 1.06 would be somewhere over here. So that 0.8554 is going to represent this area. So what would we do to find the area to the right? You have to do 1 minus that area, 0.8554. And this will give us 0.41446. 0.1466. Okay, so that gives us the area to the right of this z-score. Just for fun, let's take a look at our z-chart. What would negative 1.06 be? Negative, all right, we'll erase that so we can see. Negative 1.06 is exactly what we got when we subtracted, because this is symmetric. So if I'm looking at this area over here, it's going to be the same as that area there. So I could, instead of doing the 1 minus, just look up the opposite of that when I'm looking to the right. Okay, let's take a look at the last one. Find the area under the curve between these two. So what we'll do is we'll find the greater area and take away the smaller. So what we're going to do is we're going to find the whole area to here and then take away the part we don't need. So we're just left with that middle part that we do need. So let's take a look at this particular one. In this one we are looking at negative, a z-score of negative 2.1 and a z-score of negative 1.35. Let me erase these so we don't get confused. Negative 1.35, so you go over to the 5. There we go. This one has a value of, the area is 0.0885, a negative 2.16, 2.1 and 6 would give us here, and that has a value of 0.0154. So if we wanted to find the area between the two, to do between the two, we're going to have to subtract these. And we'll take the greater and subtract the least. So we have 0.0885 minus the 0.0154. And this leaves us with an area of 0.0713. 0.0713. And this gives us the area between those two z-scores. Now, I also want to show you how to use your calculator to do this. If we wanted to find the area under the curve using our calculator, how would we do it? All right, calculator, there we go. To find the area given a z-score, we're going to hit second and VARs. And what we're looking for is a normal CDF. And then we're going to enter our some small number, like negative 50 will work. Any small number. This is a standard deviation that's so far away it's almost 100%. And then we're going to enter our z-score. Okay, our first z-score was negative 0.99. So we'll do negative 0.99. And this gives us 0.161. It would round to 1. Let's take a look back and see what we got when we were on that page. What did we get for the first one? 0.1611. Same thing. All right, now let's do the same process. Normal, because we're working normal curve. Okay, and we want negative 50. No, this time we want to the right. When we go to the right, this is to the left. To the right, we'll start off with the z-score and go up to a big positive number, say 50. I just use positive and negative 50. We got 0.446, excuse me, we got 0.441446. Let's see what we got here. 0.1. Ooh, did I read the chart right on that one? Let's go back and take a look at that chart. At positive 1.06. I did not. I wrote it right there and copied it wrong. Okay, good. There we go. Sorry, guys. This was supposed to be 0.1446, and that's exactly what we got on the calculator. So if you want to do to the left, you do normal CDF, negative 50, comma, your z-score. If you want to do to the right, you do normal CDF, your z-score, comma, positive 50. That's how you can find the area under the curve using the calculator. All right. Now, let's see how we'll actually use this on a problem. The GRE and the MAT are tests that graduate students use to evaluate applicants. The GRE scores are normally distributed. Okay, so it tells me they're normally distributed. So that tells me I can do a standard normal distribution conversion on it with a mean of 1,500 and a standard deviation of 300. And the MAT are normally distributed with a mean of 50 and a standard deviation of 5. You decide to take both. Your score on the GRE is 1875 and 57 on the MAT. On which test did you score better? So when we're comparing apples and oranges, two different things, it's nice to be able to come up with a central way of making those conversions. And so what we're going to do is convert this to a z-score. So first we'll do the GRE. So we start off with what you made. Your score minus the mean, divide by the standard deviation. And the standard deviation of this one was 300. Okay, so our z-score for the GRE is a positive 1.25. Now let's find our z-score for the MAT. For the MAT, you score a 57. The mean is 50. Divide by the standard deviation. So your z-score for the MAT is a 1.4. Well, which one is higher? The MAT. So which test did you score better on? The MAT. And we can even do the conversions to figure out what your percentile would be compared to the population. If we looked up the 1.25 would have you in the 89th percentile. It's a percentile of 0.8944. You would be in the 89th percentile, which is pretty good. Now, if we looked up the 1.40, that would have you in almost the 92nd percentile. So that would have you at 0.9129. Okay, you have several problems out of your book to do. You want to do the conversions and look up your z-scores. You may use your chart. You may use your calculator. And we'll talk about both on Monday. Have a great weekend.